Welcome. Today we're talking about steel, the backbone of our modern world, from buildings to cars. But steel production has a significant environmental impact, accounting for somewhere between 7 and 11% of global carbon dioxide emissions. Traditional methods rely heavily on coal, which isn't sustainable if we want to meet climate goals. This challenge is sparking innovation towards what's called green steel. Steel made with processes that dramatically cut or even eliminate greenhouse gas emissions. So, how can we make steel greener? Several key technologies are leading the charge. The frontrunner seems to be hydrogen-based direct reduction, often shortened to H2DRI, combined with electric arc furnaces. Instead of coal, this process uses hydrogen, ideally green hydrogen made using renewable energy, to remove oxygen from iron ore. This creates something called direct reduced iron, or sponge iron. The great thing is, the main byproduct here is water vapor, not CO2. This sponge iron is then melted in an electric arc furnace powered by renewable electricity to produce steel. Many projects around the world are already building or planning these hydrogen-based plants. Another major route is recycling. Steel is fantastic because it can be recycled over and over without losing quality. Electric arc furnaces, or EAFs, are perfect for this. They use powerful electric arcs to melt down scrap steel. When these furnaces run on renewable electricity, this method can cut emissions by 75 to 80% compared to traditional steelmaking. So, improving scrap collection and using more EAFs is a huge part of the solution. Beyond these two main paths, other promising ideas are emerging. Technologies like molten oxide electrolysis aim to directly separate iron from ore using only electricity. Green ammonia, derived from green hydrogen, could also be used as a reducing agent instead of pure hydrogen. Plus, simply improving process efficiency through better technology and digitalization can save energy and reduce waste. Some are also exploring sustainable biomass to replace fossil fuels in certain steps. What about carbon capture? You might hear about CCUS, carbon capture, utilization, and storage. This involves trapping CO2 emissions from existing plants. While it could help reduce emissions from older facilities that are hard to change overnight, it faces big hurdles in the steel industry. It's costly, uses a lot of energy itself, is complex to implement in integrated steel mills, and there are questions about long-term storage. For steel, it's generally seen as a transitional or limited solution compared to hydrogen or scrap-based methods. Of course, this massive shift to green steel isn't easy. Green hydrogen and the renewable electricity required are still more expensive than fossil fuels. We need huge investments in new infrastructure, renewable power plants, hydrogen production facilities, and transport networks. Securing enough high-grade iron ore suitable for the new processes and enough high-quality scrap steel is also crucial. And scaling up these new technologies to meet global demand is a significant undertaking. Supportive government policies and international standards are vital to drive investment and make green steel competitive. So the path forward really requires a dual approach. Decarbonize primary steel production using methods like hydrogen direct reduction, while simultaneously maximizing the use of recycled scrap and electric arc furnaces powered by clean energy. The challenges are real, but investments are flowing, pilot projects are proving the concepts, and innovation continues. Achieving green steel is absolutely essential for our climate goals, and it represents a fundamental transformation for this vital global industry.